Hi everyone, today we're starting our new chapter and we're going to be working with position, velocity, and acceleration functions. And this is one of those big topics again on the AP exam. So a lot of this you'll see connections to physics. So some of this may not be so new, it may just be new in how we handle it in calculus. So let's go ahead and start going through some vocab and examples. So the first thing we have to be familiar with is our position function. So the position function for an object moving along a line, say the x-axis. So a lot of times we'll talk about things that are either moving along the x or y-axis. And this just describes the location of an object of any given time. So it just tells us where that object is at. And a lot of times you'll notice we use the function s for position. So you might see s of t for position. So for example, it says a dynamite blast propels a heavy rock straight up with a launch velocity of 160 feet per second. It reaches a height given by this position function after t seconds, and it wants to know how high does the rock go. Now, what I want us to know here is if they're asking how high, we want to know the maximum of that function. And what I want you to realize here is we've already worked with finding maximums and minimum values of functions, right? Before we knew to find the max, we had to take the derivative and then we set it equal to 0 and then we solved for x. So let's see how that would apply here. So it reaches a height at that's after t seconds. We need to know how high does it go. So first I need to know the time when it reaches its max. So I'm going to take the derivative. So I'm going to find s prime is equal to 160 minus 32t. That equals 0. So now I can set that equal. So 32t equals 160. And if I divide, I will get, what do I get? T equals 5. So that tells me it reaches its max at t equals 5, but now I need to plug that in. I need to find s of 5 to find out how high it actually goes. So I have 160 times 5 minus 16 times 5 squared. And I'm going to use my calculator. And I get 400, and it looks like my units were feet. So again, that position function is just telling me where is my object at a particular point in time. Now, displacement is a little bit different. Displacement of an object describes how far an object is from where it started. So it's not telling me where it's at, it's just telling me how far it is from where it started. So if I'm looking over an interval, let's say from an initial time to some other point in time, my displacement is going to be s of t sub 1, so the position where it ended, minus the position where it started. So we have our same scenario here. Right, our same position function, and now it says at 4 seconds, how far away is the rock from where it started? Right, this question we have to recognize as displacement. It's not asking where it is at the time 4 seconds, it's asking how far from where it started. So I know I'm going to do s of 4 minus s of 0. So let's see, s of 4, I'm going to use my calculator again. Is going to give me 384 minus s of 0. Well, that's just going to give me 0. So now my displacement is 384 feet. Okay. Next thing we're going to be working with is average velocity. The average velocity of an object over a given time interval describes the average rate of change of the object. And for this, we use the regular slope, right? We've been finding average rate of change over and over and over again, and it's going to be the same, or excuse me, we've been finding, the average rate of change, which is what our average velocity is. Now, velocity can be positive or negative because it describes how fast an object is moving and the direction that it's traveling. So again, just to review, let's say I'm looking again over that time interval from t sub 0 to t sub 1. My average velocity, sometimes you'll see me do this, for my average velocity, is just going to be s of t sub 1 minus s of t sub 0 all over t sub 1 minus t sub 0. Now you'll notice, right, just to review, this, what we have in our numerator, is just what we previously defined as the displacement. So the average velocity is the displacement over the change in time. All right, so we're going to go back to our familiar scenario here. Now it's asking me the rock's average velocity over the time interval from 0 to 3. So I know my average velocity is going to be s of 3 minus s of 0 all over 3 minus 0. So let's see here. Hopefully you guys are checking my numbers. I'm going to get 336. S of 0 is just going to give me 0, so 336 divided by 3 is going to give me 112. Now, here we have to be careful with units. We always want to have units in these problems. My measurement, or my units for displacement is feet. My measurement and time here on the bottom is going to be seconds, so my average velocity is going to have a unit of feet. I don't know why I keep saying feet, of feet per second. All right, now we get down to instantaneous velocity. And hopefully by now, when you see instantaneous, like when we did instantaneous rate of change, we're thinking about a derivative, because we're talking about how something is changing at one specific point in time. So the instantaneous velocity is the derivative of the position function, and it describes how fast an object is moving at a given moment in time. Now, you'll notice for velocity, a lot of times we use v of t, and again, that's going to be the first derivative of our position function. All right, so now, again, same scenario. We have our position function. So the question says, what is the velocity of the rock when it is 256 feet above the ground on the way up? So we actually have a little bit of work to do here. If I'm going to find the velocity at a given time, first I have to figure out when is the rock 256 feet above the ground on the way up. So the first thing I need to do is figure out when my position function, when is my rock at 256 feet above the ground? Now, if I'm thinking of a rock, I know this is going to be launched up and it's going to come back down. So I'm going to hit 256 feet at two different points. However, if I want it on the way up, I know I'm looking for this point here. So let's see, if I'm going to factor this, I want to set it equal to 0, so I'm going to move this over. I have 16t squared, I just want to make that positive, minus 160t, and then plus 256 is equal to 0. Now hopefully, if we're lucky, we can factor out a 16. So that's going to be t squared. This is going to be minus 10t, and 256 divided by 16 gives me a positive 16. So now I can factor this. I have t minus 2 and t minus 8. Negative 2 times a negative 8 gives me, oops, I'm sorry, I went off the screen here. There we go. Negative 2 times negative 8 is that positive 16, and a negative 2t minus 8t gives me the negative 10t. So now I have t equals 2 and 8. But again, since I want it on the way up, I'm only concerned with time t equals 2. So now what I really want is the velocity at time t equals 2. Well, we said velocity is the derivative of position, so my velocity function is going to be 160 minus 32t. So then velocity at time 2 is 160 minus 32 times 2, which is going to give us a velocity of 96 feet per second. All right, moving on. The next thing we're going to look at is when we're moving right versus moving left. And this is an area where you're going to see a big connection to what we were doing when we were analyzing f prime, analyzing that derivative to tell us about the function. So when we're trying to decide if we're moving right or left, we look at the sign of the velocity function, right? The velocity we know is the derivative of position, so we're looking at the sign of the derivative, just like we did last chapter when we wanted to know if we were increasing or decreasing. All right, so again, we have our same function here, our position function. We want to know when we're moving right and moving left. So moving right means velocity is greater than or equal to 0, and then moving left is going to be when our velocity is less than or equal to 0. Again, since we're looking at a first derivative here, we're going to be working with closed intervals. So the first thing I need to do is take my derivative. So velocity equals the first derivative of position, which is going to be 160 minus 32t, and I'm going to set that equal to 0. So now I'll have 32t equals 160, which means t is equal to 5. So now, much like we did before, I'm going to make a table for my velocity function. And let's see, in this case, since we're dealing with motion, we look at time greater than 0. It wouldn't make sense to talk about negative time. So 0, and then 5, and then infinity. And now I'm going to test intervals just like we did before. So if I think of a positive 1, if I plug in a positive 1 here, that's going to give me a positive value. Now if I think of plugging in 6, if I think of 160 minus 32 times 6, that's going to give me a negative value. So I'm doing my sign analysis just like I did before, and now I can say that the object is moving left, or excuse me, let's start with right. Moving right on the interval, again I'm going to use closed brackets here, so on 0 to 5, because b of t is greater than 0. Now on the other hand, I could say the object is moving left on the interval from 5 to infinity because my velocity, that sign is negative, or velocity is less than 0. So a lot of this work flows directly out of what we did last chapter. All right, I know this is getting long, but kind of hang with me. We'll have a bunch of vocabulary after this, which will allow you to get into a lot of the practice in class. All right, now speed. The speed of an object is the absolute value of the velocity. So for speed, we're just looking at how fast this shouldn't say and, but fast an object is going, and we ignore the direction of travel. So we only care about how fast. So speed, notation-wise, a lot of times you'll see the absolute value, absolute value of velocity. So we have our position function here. The question says, what is the speed of the rock when the time is 2 seconds? Again, that means then speed is going to be our absolute value of the velocity at time 2. So first we need our velocity function, which is 160 minus 32t. Velocity at time 2 is going to be 160 minus 32 times 2, which is 96 feet per second. And in this case, since that's a positive value, our speed and our velocity are going to be the same. All right, a few more things and then we are good for now. All right, next one is acceleration. So acceleration tells us how fast the speed of the object is changing. So therefore, it is the derivative of velocity with respect to time. So for acceleration, a lot of times we'll use a of t, which is v prime of t. So our question, we go back here, it asks us the acceleration of the rock at time t equals 2 seconds. Well, since I have position, I have to start off by finding my velocity, which is going to be 160 minus 32t. Now I find my acceleration function, which is just going to be negative 32. So actually the time doesn't matter here. I have a constant acceleration, and now I know that's going to be feet per second squared for my units. All right, the last piece for today is talking about speeding up or slowing down, or sometimes you'll see it phrased as the speed is increasing or the speed is decreasing. So we can tell that an object is speeding up by looking at both the velocity and the acceleration functions. So if velocity and acceleration have the same sign, so both positive or both negative, then the object is speeding up. However, if they have opposite signs, then the object is slowing down. So we need to take both of those functions into account. So in our example, our question is asking, is the particle speeding up or slowing down at time t equals 2 seconds? So I know I need to compare the signs of v of 2 and a of 2. So for velocity, I know we've done this before, but it's an easy function to work with, so I'm just going to do this again, is 160 minus 32t. So my velocity at 2 is 160 minus 32 times 2, which is going to give me 96. Now my acceleration is just a negative 32. So acceleration at times 2 is negative 32. Now, since my velocity is positive and my acceleration is negative, I know the particle is slowing down at t equals 2 seconds because velocity at times 2 is greater than 0 and my acceleration at time 2 is less than 0. And that's how we would justify it. All right, I know that was a long video, so thank you for hanging in there. You'll have a chunk of time to work on this kind of basic position, velocity, and acceleration problems during the block tomorrow, and then you'll move on to the next piece of this. All right, see you in class.